Solving radical equations. We've gone over this a few times at this point, but I just want to keep emphasizing this, that an expression is just a mathematical statement. And so for an example, a radical expression might look like root 2x plus root 5. It's not equal to anything, it's just a statement. An equation has to have an equal sign. So that means that in the end, we might be able to solve it, which again, to solve is find the value of the variable that makes the equation work. So in a radical equation, that might look like root 2x plus root 5 equals 3. Now, we might be able to solve that, and it might turn out that this is an impossible equation to solve. And I just made it up off the top of my head, so I don't know at this point whether it is solvable or not. But by the end of this video, we'd be able to figure that out. The strategy for any equation is to isolate x. That doesn't change for a radical equation. But it does mean that our first step is going to be to isolate the radical and then square both sides to get rid of the radical. So we'll start with a really straightforward example, which is that the square root of x minus 3 equals 0. So we start by trying to isolate x, but that means isolating the square root of x, because the square root of x is the last thing that we have to deal with in our solution. So add 3 to each side. That means I have square root of x equals 3. Now I want to get rid of the square root, and I do that by squaring each side of the equation. The square root, or I should say the square of a square root, those square and square root operations cancel each other out, leaving me with just x is equal to 3 squared, which is 9. Now, to confirm that we have a proper solution, what you can do is you can throw that back into our original equation. So the square root of, again, our original equation being up here. So the square root of, if x is equal to 9, that would be the square root of 9 minus 3 equals 0. So the square root of 9 is 3. Does 3 minus 3 equal to 0? It does, so we can confirm that our answer is indeed correct. In this next example, it looks a little bit more complex, but our strategy is going to be the same. We need to isolate x, but before we can do that, we just need to start by isolating the radical. So we add 9 to each side, and I'm left with square root of 5x minus 4 is equal to 9. And now, in order to get rid of the radical sign, I'm able to square each side. So square root squared goes away, and I'm left with 5x minus 4. And 9 squared is 81. Now I'll add 4 to each side. And basically at this point I'm just solving a linear equation, which is something we've done many times before. So if you need a little refresher on that, you can go through that, but we should be comfortable with these steps at this point. So that's 5x equals 85, then we divide by 5, and we get x equals 85 over 5, which I have to do in my calculator, because that's outside of my memorized times tables. So that's x equals 17. And one more example. The only difference here is that we're going to have a coefficient 3 times our radical, but we're going to go about it with the same strategy, which is just to isolate that radical at the beginning. So add 8 to each side. 8's the loosest thing that's connected to that radical. So we get rid of it first. So I still have 3 times 3x minus 5. And now that 8's been kicked over to the other side. So 4 plus 8 is 12. And then I'll peel off this 3. So the 3 beside the radical can be divided off. So divide each side by 3, and I'm left with the square root of 3x minus 5. And on the right-hand side, I have 12 over 3, which is 4. Now I'm ready to square each side. Gets rid of that radical on the left, leaving me with 3x minus 5 is equal to 4 squared is 16. And now go about solving. So I'm going to add 5. So 3x equals 16 plus 5 is 21. And then divide by 3, and 21 divided by 3 is 7. So my answer is x equals 7.